Okay, the next thing we're going to cover is a quick recap of multiplying scalars. Okay. First off, this red line I've drawn, we're going to call this vector A, let's say. Okay. So this is vector A. It represents a direction. It looks like it's not quite 45 degrees, a little, maybe 60 degrees northeast. Give it an estimate. And it's probably something like 3.5. We'll call it 4 in terms of magnitude. So we'll call it maybe 4 kilometers, something like that. It would be the magnitude of this vector. Now, a scalar is putting a value in front of the vector to either change its direction, like we did with a negative. Technically, a negative sign could be considered a scalar, and or changing the length of the vector. So what we use to represent the scalar is usually the letter k. Okay? And we're going to talk about how k, and what we usually do is put k in front of the vector, so we would say k be representing any number in front of the vector will affect it. We talked about how if k yesterday was greater than 0, it goes the same direction as the original vector. It's the same direction. We talked about this yesterday. If k is less than 0, it goes in the opposite direction, which makes sense with what we talked about the other day because a negative vector would change the direction of it. And then finally, if k is greater than 1, it makes the vector larger or longer. And if k is between 1 and 0, it makes it shorter. Okay. And we'll show you some quick examples of that. Let's go down. Okay. Actually, I'm going to copy that vector from above. Okay, so we have vector A. Talk about the different ways we can represent it. Come on. There we go. Okay, so vector A. It's over here. Let's say we're looking at vector A, but the scalar, or the number we're going to multiply by, is the number 2. So we're going to say that k is equal to 2. And what ends up happening in this one is we're going to get a vector that is essentially twice as long as the original, but in the exact same direction. So I'm going to stack these two. So this here represents 2 vector A. If you notice, it's twice as long as our original vector, but it's still in the same direction because it's a positive number. Let's say we had a scalar of -3. Okay. In that case, we're going to have a vector, hopefully this is going to fit on the page, that's going to be 3 times as long as our original. But I'm unable to flip the arrows, so you just kind of imagine it with me. I'm going to put a big arrow at the end. This vector is going the opposite direction of our other 2. Okay, and we knew that from before because we knew a negative vector changes the direction. So a number greater than 1 lengthened our vectors, as you guys can see. And when it was less than 0 or negative, it changed the direction of the vector. Now the other option is if we have a vector, something like let's say k is equal to, I think a half will be easier to do. So we have our original vector, but it needs to be shrunk essentially by a half. So I'll do my best. I'm going to say right there is roughly where it is. So still in the same direction because it is a positive, but this represents a half of vector A, which essentially has half the magnitude of the original vector. Okay? So when we draw things to scale, this would be considered to scale. This has vector A being a set length of something like 4. Very much. We said that the magnitude of A was 4 originally. Vector 2A, what would the magnitude of this one be? Anyone know? 8, yeah, 2 by 4, so the magnitude of this would be 8. Now, because we're talking about just the magnitude, the way we'd represent this is we'd say A, the absolute value, if you guys recall, is 4. The absolute value of 2A is 8. Why do I call it the absolute value? Why don't I just say that vector 2 vector A is equal to 8? Anyone know why I put the absolute value around it? We're only multiplying the magnitude, that's right. Why don't I just say, without the 2 lines on the side, why don't I just say 2 vector A is equal to 8? It would be considered just a scalar. Okay, that's right, our magnitude can't be negative. Why? Well, that's right, why can't it be negative, or why don't we care if it's negative?
Because it's a distance, and this is usually the positive direction.
Okay, we usually talk about positive direction, yeah?
The absolute value, because you're always saying the value, not the direction.
Yes, the direction is what's very important here. The reason we're calling it absolute value is because I can't say that 2 vector A, I can't actually represent that direction. If I just say it's 8, like you said before, that's just considered a scalar. I have no idea what direction this is going in. Therefore, and that brings me to this idea here, k being negative 3, or this one here was negative 3 vector A. Okay, I would say the absolute value of negative 3A would be what? 12, that's right. Okay, so if I say the absolute value is 12, I still have a positive direction. Had I said it was negative 12, it doesn't really mean anything to us because we still don't know the direction of this vector. Okay, like we said, vectors must have magnitude and direction. So we represent it as an absolute value. And finally, what would half vector A, or the absolute value of 1/2 vector AB? 2. Okay.